Alright, welcome back to my channel. In today's video, we have two parallel circuits, namely R1 7 ohm, R2 7 ohms, R2 9 ohms being connected in parallel, and we have R3 12 ohms connected in series to the two parallel circuits. And we have a voltage drop of 15 volts across 12 ohms. Let me explain small so that you can easily understand. Now, this voltage drop divided by this R3 will be the same total amount of current that will flow through across this parallel circuit. Meaning, the current that we are going to find in R3 will be the same total current. When the total current moves through, part will flow here and part will flow here. Meaning, the current in R1 and the current in R2 will be the current in this R3. So let's do it. So we are going to find the current in what? R3. So what we say is the current in R3 is equal to the voltage across the series. So voltage drop across the series circuit over R3, which is going to give us 15 volts over R3 is what? 12. And 15 divided by 12 will give us 1.25 amps. So now this will be the current. So here now we say current in R3 is equal to what? 1.25 amps. Alright, so since now we have 1.25 amps, then, just as I say, this same 1.25 is what will move along this side to this side, 1.25 amps. But when it gets here, part will flow here. So here we are going to have current in R2, and also part will also come here. We are going to have current in R1. Now, what we have to do is that we need to find the total voltage. But before we can find the total voltage, we need to find the parallel resistance equivalent, and then we add it to this. So what we have to do is we can go straight forward and we'll say what? Okay, so we have our total parallel resistance equivalent, which is going to be what? R1 times R2 product over sum. R1 times R2 over R1 plus R2, which is going to give us what? 7 times 9. 7 times 9 over 7 plus 9. So 7 times 9 will give us 63. 63. 7 plus 9 will give us what? 16. And therefore, 63 divided by 16 will give us what? 3.94 ohms. Approximately, we will say our total parallel equivalent will give us what? Approximately 3.94 will give us 4 ohms. Now that we know our total equivalent in this parallel circuit, then now we can say our R total, which is the total resistance, will now be what? RPE. So total equivalent resistance, which is RPE plus R3, which is 12. So our total resistance is going to be what? Our RPE is what? 4, which is the total parallel equivalent resistance, plus 12. So our total resistance is going to give us 16 ohms. So now that we know our total resistance, then now, since current in R3 is the same as total current, then now we can say, so that means R3, current in R3 is the same as 1.25 amps as we have here, and is the same as total current, which is what? 1.25 amps. So that means we can now find our total voltage as what? total current times the total resistance, which is 16. Total resistance. So it's going to give us our total current 1.25 times our total resistance 16. So we are going to have our total voltage as what? 1.25 times 16. 1.25 times 16 will give us 20 volts. Now that we have our total voltage, we subtract this total voltage we subtract this 15 minus 20. So now we'll say voltage across para, because we need to get the voltage across para before we divide by each of these. Then we'll get the current here and the current here. So we say voltage across para equal to what? Total voltage minus the voltage across series, which is going to give us 20, which is total voltage, minus 15. So total voltage across para will be 5 volts. So now we can say now current in R1 is equal to what? Voltage in para over what? R1, which is 7. So 5 divided by 7 will give us 0.71 amps. Then current in R2 will be voltage in para over 9, which is going to give us 5 over 9 is going to give us 0.55 amps. So this is the current. So now the current in R1 is this 0.71 amps, and the current in R2 is 0.55 amps. When you add these two, either you get 1.25 or 1.26 approximately due to tolerance. All right, so this is the answer for this case. Continue to follow me, share my videos, and like my videos. Bye for now.